Welcome back. In this video, we're going to be talking about measurements. When the scientific revolution happened, basically there was a need for a common set of measurements. Okay, and physics is an experimental science, so you're doing a lot of measurements. So having this common set of defined units is important. And for our world, le système international de unité. I don't know, it's French. That is the SI, those are the SI units, okay? And the SI units are the standard. And sometimes you probably know the metric system, so it's the same, basically the same thing. SI units are the metric system that you learned in past science classes. So in this course, we're specifically going to focus on 4 SI units. So the units for time, length, mass, and electric current. Okay, for time, the base SI unit is the second. Okay, so the abbreviation for that is a lowercase s. For length, the SI unit is the meter, and a meter is about, well, not exactly, but very close to 3.28 feet. For mass, the SI unit is the kilogram. That's the base unit. The kilogram is kind of interesting because it's the only SI unit that has a prefix as the prefix in the base unit. All the other ones are kind of sans prefix. But the kilogram is the base unit for mass, and 1 kilogram is equal to 2.2 pounds. Again, about equal to 2.2 pounds. In the second half of this class, we're going to talk about electricity. And electric current is measured in the ampere. So electric current is like how much charge is flowing per unit time. So the unit for that is the ampere, and the abbreviation is in uppercase A. And 1 amp is equal to 1 coulomb of charge per second. So again, we'll go into that later in the course. For now, let's talk about how we convert between units, because we just looked at what the base units are for those 4 dimensions or quantities, and we don't always see measurements taken in those units, right? So like for time, you could have units of the second, but you could also have minutes, hours, days, years, a century, and like for length, yes, the base unit is the meter, but you can also, there's a ton of other units that you can use for measuring lengths. Same with mass. Okay, and you'll notice some of these in here that I stuck in here are the ones that we're probably more familiar with here in the US. But it's convenient to know how to convert between units. And the way we do this is we look at the 2 quantities and say, okay, well, how much of one equals another? So kind of ratio of the 2 quantities. So for example, like there's 60 seconds in a minute. That's a useful piece of information. That will allow us to convert from seconds to minutes. Or we know that there's 1,000 meters in a kilometer. Again, useful piece of information. We can use it to convert any given measurement in meters into kilometers. And same for the rest of these. Okay, there's a special name for these kind of equalities here. We call them conversion factors because they help us convert between units. So conversion factors are just special forms of 1 because they're equal to each other. If you put them in a little ratio here, so like 60 seconds equals 1 minute, so 60 seconds over a minute equals 1. Okay, we could also write it the other way. 1 minute over 60 seconds equals 1. These are just kind of special forms of 1. Okay. Same with basically any of those things I had on that last slide. 1 inch equals 2.54 centimeters, so you can put 1 inch over 2.54 centimeters, that equals 1, and also 2.54 centimeters over 1 inch is going to equal 1. So, okay, why is that important? Well, now you can take those special forms of 1, those conversion factors, and multiply by those to change your units. Okay, you can get unwanted units to cancel out. So let's take a look. If we were trying to convert 360 seconds to minutes, we're not trying to change that amount of time. We're just trying to report that amount of time in minutes instead of seconds. So we take 360 seconds and we multiply by 1 minute over 60 seconds. Okay, that's going to cancel those seconds and we're left with the units of minutes. I take 360 divided by 60, that gives me 6. Okay, again, I know that's a very simple example. You did not need me to walk through that. However, that's helpful to understand this simple example when we move to having more conversion factors in a row to do our unit conversions. Okay, so it's important to remember that the quantity has not changed. So the amount of time has not changed. We're just reporting it with different units. Okay, so we went from seconds to minutes. So you can actually use as many conversion factors you need to arrive at the necessary units. So let's say you were trying to convert 2.5 days into seconds for some reason. Well, you know there's 24 hours in a day, you know there's 60 minutes in an hour, you know there's 60 seconds in a minute. And technically, yes, you could combine this 3,600 seconds in an hour if you wanted to. But just for this example to show what you do when you have multiple conversion factors in a row, let's keep it like this. Okay, so we write down our 2.5 days, and then we're going to write the conversion factor that takes us from days to hours. Okay, so we know we need to cancel those days, so we go find our conversion factor with days in it. Okay, well, we're going to go to hours from days. So we put days in the denominator, it cancels out, the units cancel out. Okay, we're in hours now, so let's go find our conversion factor that has hours. Okay, well, we're going to go to minutes, so we put minutes on the top, hours on the bottom, so our hours cancel out. Okay, and then our last conversion factor here, well, minutes, we need minutes to cancel, so let's put that in the denominator. And now our units are good. Okay, so now we can go ahead and do the math. Well, we got 2.5 times 24 times 60 times 60. Okay, we would divide by 1, but there's nothing in the denominator except for 1. So we just need to multiply those on the top, and we get 216,000 seconds. Okay, so that successfully took our units from days to seconds. Okay, switching gears here a little bit. So with numbers, sometimes you deal with some ridiculous numbers that have tons of zeros. Okay, so scientific notation is a way to represent those numbers that have a ton of zeros. They're either really large numbers or really small, really tiny numbers. So in scientific notation, you express the number as a number between 1 and 10 multiplied by 10 a certain number of times. Okay, here's my number. I got 150, I think that's million. Yeah, thousand, million, billion. Okay, 150 billion. Well, a number between 1 and 10 that's a multiple of 10 here is 1.5. Okay, so 1.5, and then I'm going to have to multiply by 10 3, 6, 9, 10, 11 times to get to that 150 billion. Okay, so my number in scientific notation is going to be 1.5 times 10 to the 11th meters. So, okay, it's a positive exponent here because I need to multiply this number here by 10 a certain number of times to get out here. And in this case, I need to multiply by 10 11 times. Okay, but if you have a really tiny number, you're going to do something similar, except for you're going to have to divide by 10 instead. So here I find my first non-zero number, that's a 1, and I put a decimal place right after it. So 1.1, and so 1.1 I would have to divide by 10, 3, 6, 9, 10 times to get to this number here. Okay, so I'm going to write my number in scientific notation. It's going to be 1.1 times 10 to the negative 10. So 10 to the exponent of negative 10 really means 1 over 10 to the 10. Okay? So that means the negative exponent basically means you're dividing by 10 that number of times. Okay, so we see here negative exponent means you divide by 10 that number of times to reach back this like standard form number. Okay, but it actually can get a little bit easier than that. You don't even have to write that much down. So there's metric prefixes that you're probably familiar with, at least with kilo, centi, and milli. Might even be familiar with micro, nano, mega. Those you hear in everyday life. The other ones maybe not so much. But these are super useful because you can replace those powers of 10 with a prefix. Okay, so, and you get an idea of like the order of magnitude, which you do with the power of 10 too, but it's kind of nice to have a prefix that you can use. Okay, so we have these prefixes here. There's not one for every single power of 10, but usually you're pretty close to one of the powers of 10. So we have 1.15 times 10 to the 11th. Okay. Well, we could go here or here. So let's just go, I don't know why, let's choose giga. Okay. So we're going to try to report this in giga meters. Okay. So let's rearrange this. Well, if this was rewritten as 10 to the 9th, well, I'm making this 150 because I took away 2 powers of 10 out here. So if I took away 2 powers of 10 here, I need to multiply this part of the number by 10 twice so that I don't change my overall value. Okay, so now I have 150, and this 10 to the 9th meters can be replaced just with gigameters. Okay, so that'll replace the scientific notation part, and we just have 150 gigameters that we're left with. Okay, so same thing here. Let's look at this one. We have 1.1 times 10 to the negative 10th. So we're close here to nano. Nano is 10 to the negative 9th. So let's go ahead and move that decimal one place to the left to make this 10 to the negative 9th. Okay, so I made this is actually getting bigger, right? Because I'm going from 10 to the negative 10 to 10 to the negative 9. So if you picture a number line, you're actually getting bigger. So then I need to make this part of my number, if I added a factor of 10 over here, I need to get rid of a factor of 10 right here. Okay, so now I'm at 0.11 times 10 to the negative 9th, so that 10 to the negative 9th is going to be replaced with nano. And I got 0.11 nanometers. Okay, so scientific notation and the prefixes, they can actually be used together too. But it's a good idea to start becoming familiar with these if you're not. And also becoming familiar with scientific notation. I know if you took chemistry last year, and maybe you can think back to even freshman year, you did a little bit of this, but it'll be super useful to just familiarize yourself with these prefixes and the use of scientific notation. Okay, that's all I got for you in this video. Thanks for watching.